Hey guys, we are looking at a Heatcraft psychometric chart. We're going to start getting into how the psychometric chart works and how we can use it on a service tech level. We're not going to get into engineering and all sorts of crazy stuff. We're going to get into how we use it in the field, how we can better understand what's going on with our systems in the field by using this chart. What we're going to do is we're going to look around the different terms on the chart for today. We're not going to get into anything else besides just getting sort of a familiarity with the chart, looking at the different terminology, sort of understanding on a basic level what it means. So let's go ahead and look in at some of the terms on the psychometric chart and see what they mean. The first number we see is enthalpy Btu per pound of dry air. That's going to refer to, think of it as the total energy in the air, a sum of both the sensible and latent heat in the air. It's a cumulative. Remember how we talked on the Pistons, the TXV video, about even though how Vegas was so much hotter because it was dry, had a low latent heat, the North Carolina humidity and heat actually came out to a higher enthalpy because it's a combined measurement of both the latent and sensible heat. And as we get into the chart, we'll explore that a little bit more. That's one of the more important measurements that we'll use in our field work. Dry bulb is just our standard sensible heat measurement. Just like you take your thermometer outside to see how hot it is outside, all you're measuring is the dry bulb temperature, the sensible heat. It doesn't take into account any latent heat, humidity, anything like that. It's just a standard measurement. The same as what's displayed on your thermostat. Just a very simple measurement and one of the most important ones we use. We have a few terms on the right side of the chart. Dew point temperature is a temperature of air in which it can no longer hold the water that it's containing. There's water vapor in the air. It's always a mixture of air and water. When it gets to a certain temperature, it has to release that water and it condenses out, and that is the dew point temperature. We've all seen it. We wake up in the morning and there's dew on grass because there's a certain temperature in which the air can no longer hold the water and it has to condense on solid surfaces. We have sensible heat ratio, which is the amount of sensible heat compared to the total amount of heat, because there's sensible heat and there's latent heat, which takes into account humidity and water. All that is just getting a percentage of sensible compared to the total. And we'll go into all these terms a little bit more. Vapor pressure. Vapor pressure is the water vapor pressure in the air. We'll use that when we calculate the actual CFM. Humidity ratio is how much water is contained in the air. You can find out how much water has been taken out of the air when we draw our process lines on the chart. But we'll get into all those, just have a basic understanding of what each one means.